Okay, this is a video that I'm producing, working with my kids in AP Chemistry on microscopic particles and the forces between them. So here are my kids working on the whiteboards with their assigned topics. They're going to be drawing them out, showing bonds and intermolecular forces between them, and we will be going through different questions, etc. So I'm going to hand this off to one of my students, and when they're done, we'll go through it. So if you want to just work around there for a little bit. Hey guys, about 30 seconds. Is that enough?
For what?
To finish? The first one.
Yeah.
Is that what it says?
I don't know if you wanted like a.
Looks like a boot.
Yeah, I mean, it wasn't.
That's fine. That's fine. Okay, I'm just picking them. Okay.
Okay.
Say what?
Is it H?
It's just HCl. Just HCl.
Go grab another color.
Alright.
Go get another color.
Oh.
Yeah. All right. Who has questions so far? Okay. Don't forget, if it's an open container or a sealed container, I see some of you guys have that specified there, so make sure you have that.
You can go there.
Okay.
No, because then this bounce to this one, and this bounce to CL, right?
No. H no. Dot. Okay. And then this H
Yeah,
no.
yes.
All right. Make sure you put the number of the one you're doing at the top, so I can tell which one you're doing. So which one, is this number 5?
Yeah.
Put number 5 up there.
yeah.
Yeah, that's fine. All right. And you guys are done?
Yeah. With the first one.
With the first one?
With
You
the
guys are
first
done with the first one?
Yeah, almost.
All right. And
I
almost done?
mean, that's too much. We could.
You could draw once and gas, so it's kind of like.
Okay. You guys done?
Yeah, but if it's a gas, then
The O, who
the
can I
spread
pick?
on there wouldn't be many, so maybe like.
Good job, O.
Should we do one more?
Not yet, not yet. Oh, I'm seeing. That's fine. That looks okay. That looks okay. All right, here we go. Let's get started. So up here, they have done situation number 2. Okay, so up here, pay attention, guys. Here we go. Up here, we have situation number 2, where they have a sealed flask of carbon dioxide gas. Okay, so why don't you hold that up so everyone can see that, and I'm going to start asking some questions here. So I see that, what's the black spot up top?
It's sealed.
Okay, so it's sealed. Good. That's a very different flask. That's fine. Now you have depicted some bonds here. What are these right here? Polar covalent bonds. Okay, I didn't see that. All right, now you have drawn it in a bent shape. Is that the shape that carbon dioxide comes in? Okay, what is it?
Linear.
It's linear. Okay, so just be careful on this because right now these look like these are. What kind of bonds is the bent shape telling us? What kind of polarity?
It's polar.
Yeah,
So that'd be non-polar.
There would be nonpolar,
Correct.
good, okay. Now, I noticed, now, you have a little bit of, you've recovered nicely, because I see that there are no intermolecular forces. So what are the only intermolecular, so it's good you didn't do that. You didn't draw any dashed lines. So what are the only intermolecular forces for carbon dioxide?
London dispersion.
London dispersion forces, all right, good, excellent. Let's go over here. All right, hold yours up. All right, so what, you guys have number 4, a sealed flask of ammonia gas. All right, I see the cap. All right, what kind of molecule, polar or non-polar, is ammonia?
Polar,
It's a polar molecule. What's the shape?
trigonal, pyramidal.
Trigonal pyramidal, good. Somebody else answer now. What are the blue dashed lines? Hydrogen bonds, good. What's the other intermolecular force that you have going on here?
London dispersion.
London dispersion forces. Now I notice the particles are all over the place.
That's because it's a gas.
It's a gas, right? There should not be a regular arrangement or a click at the bottom. Perfect. Okay, good. All right, let's go over here to this one. You guys have what number?
3.
You guys had 3. Hold that up. Okay, so you had hydrogen chloride. Now this could be mistaken for a hydrochloric acid, but it's not. It's a hydrogen chloride. What kind of bonds? You have dipole forces. Those are the blue one, purple ones here. Oh, no, here.
Yeah.
Okay, dipole. Good. And you've drawn 3. They seem to be in an irregular pattern, which depicts what? Solid, liquid, or gas?
Oh, gas?
Yes, a sealed container of, because it says a hydrogen chloride gas. All right, good. That was an easy one. You guys got off. Okay. That's all right. Over here. You guys had what, number 5? Number 5. All right, number 5, a beaker of ethanol. You guys had to look up ethanol?
We got our packet.
Okay, good. So I see that ethanol is, do you know if that's an organic molecule or an inorganic molecule? It's got a carbon chain, do you know?
Organic.
It is an organic molecule, okay? This is something called an alcohol, okay? All alcohols have a hydroxyl group here, which is this right here. It's also responsible for what we've been talking about, which is what kind of intermolecular force will that be right here, here,
Hydrogen
here?
bond.
Those are hydrogen bonds. Can you define what a hydrogen bond is?
It's,
Bonding between H and NORF.
Yeah, H has to be directly bonded to NORF?
Yeah.
That's the start of it, right?
Yeah.
So what's the hydrogen bond itself? Is it within the molecule or between? Between molecules, good. Now I see that, what's this line in here? What's this line? This squiggly line.
oh, that's.
Oh, that's just ethanol is all below that. That's like the.
So this is solid, liquid, or gas?
Liquid.
It's a liquid,
It's a liquid,
good, good. So
yeah.
you drew it correctly, good, okay. All right, why don't you guys either use the other half or erase, and we will work on the next portion, okay? Take about a minute or two. There's, polar, non-polar. It's non-polar, okay? Go with that. Then make it easy like that, okay? Do you remember the phrase like dissolves like?
Yeah, like the
Polar
one,
goes with polar.
like the one we did yesterday with like Na and Cl.
No, this is where we have, water, which is polar. This is non-polar. They don't mix. That's a hint.
Okay.
Remember I said salad dressing? Oil and water. Oil and water. Perfect, perfect. Okay.
I was just thinking those.
Oh, did you guys see I made the mistake?
Is this supposed to be
Yeah,
H12?
I drew two of them here. This is only supposed to be
Oh,
one.
yeah.
Yeah, I'm sorry. So it's T16. It's one hydrogen on each one. My bad. I realized that over here. Okay, we ready?
No.
Yeah.
Okay, what I would do is draw one more of each.
Okay.
Kind of, well, I'm not gonna tell you how to do it. See if you can figure it out. All right, that looks good. You guys are done?
Yeah.
Excellent, excellent. Okay. And are you almost done?
Kind of.
Yeah, good, good. In water, we have a density issue. Water is more dense than hexane.
Okay.
Does that make sense? So I like where this is right now.
What's on my here?
Yes, perfect. Keep going, keep going. All right. All right. Okay, what I'm gonna do to speed things along here, I'm gonna start with the back group this time. I'll let you guys finish up, okay? All right, here we go. Different situation. Everyone, if you're not working, pay attention. Bring it up here, please. Okay, so they're on the right side here, okay? How's our pictures? Good? Okay. So they have a beaker of boiling water. So what's going on below the line?
So that's where the water is still down there and it still has the hydrogen bonding between each molecule. And then up here is where the hydrogen bonding's been broken.
Yes, and notice, I love this, they have not broken the water molecules themselves, the covalent bonds in the water molecules. Remember, a whole molecule will float away from the surface. So I actually just gave you a hint. Where does evaporation or vaporization happen? Does it happen down here or at the surface?
Surface.
It has to be the surface. It has to be at the water-air interface, okay? That's the only